So today we're going to talk about a couple things. First, we're going to look at the psychological aspects, and then we're going to go over the systematic approach to facilities design. So psychologically, whenever you are involved in a facilities redesign, you need to be concerned about the way people might react to it. I don't know if any of you have ever been in a facility, been involved in a workplace, or been involved in any kind of activity where you've been asked to change where you sit, or other people have been asked to change, especially if you get put in a place where you have maybe a smaller area to be with. That is going to affect people in quite dramatic ways. There's something primal about the way people think about where they are and where they sit and the space around them. So that's just something you need to take into account when you're redesigning a facility. The best way to counteract that is always to get the people involved from the very beginning who are going to be affected by the change. That would mean things like making sure that they completely understand why it's happening, and it actually even showing them the justifications for the activity, and also getting their input. If they feel like they have a little bit of a control for the area in which they're in, they will feel a lot better about cooperating with that. So next we're going to talk about the systematic approach to facilities design. Any problem-solving set in engineering often follows a systematic approach. So you'll be looking for a step-by-step process. And I know you've been exposed to this before throughout your time at Cal Poly, when you look at what's the first thing you do, what's the next thing you do, what's the next thing you do. So often we are guided by systematic approaches. I want to look specifically at the systematic approach for facilities design, which is listed here on the screen. So there's going to be 8 steps, but generally it follows the similar kind of procedures that you've been seeing before. Often we sometimes refer to this as DAMES, but I've also highlighted sort of 3 main steps. One is that you need to know the operations. You need to completely understand what's going on in the current system. So before you even make any changes, make any kinds of adjustments to the system, you need to completely understand what's going on. The next main thing you need to do is you develop alternative solutions. And then after that, you're going to look at deciding on which of these alternative solutions meets your criteria best. And then the last thing here we have is defining and installing maintain. That's just always a continuous improvement kind of look at these systematic approaches. So looking at defining the problems or the goals of the system, this you often have seen this, especially you're probably good at this if you've taken project management classes, really looking at, well, what exactly is the problems and what are the design specifications? What are the requirements from the customers in order, and how are we going to know if this is going to be a good solution? So one of the things you might look at is, why are we creating this new layout? What is it we're trying to accomplish? Why did it even come up? Who even asked you to do this? Why is it an issue? So really fully understanding what that is, what the need is. And then if and when you develop a new layout, how do you know it's a good layout? How do you know that this is going to be satisfying the customer? What are they looking for? And in this particular area, then you need to look for design specifications. If you have sort of capacity issues that you're trying to reach, or budgets, or any kind of other thing, maybe better ergonomics, maybe more lean manufacturing issues, whatever it is that you're looking for, not you really, but the customer is looking for in the process. I have a bunch of, in these slides, I have a bunch of pictures of old facilities projects that were done, and I just want to highlight that this one is a project that we did at Diamond Foods in Stockton, and this is one of their production lines, one of their bagging lines for their, I think they were walnuts. So just so that, and this was done in a CAD drawing. That's what the drawing was in. Mostly we're not using CAD in this class because it's just a little bit complicated to use, and and the things we do don't require the precision that CAD can give us. So one of the things that when you're talking about the goals and the problems and the customer's requirements, looking at the requirements need to be solution independent. Sort of what you're going to do, not how. So this really helps us to have the discipline that is required of an engineer, that we don't come to it saying, oh, I know your answer is this. That is not what we're doing, especially in the first 5 steps of the systematic approach. We really, really want to just be like, okay, what is the problem? What is it that you want done, not how we're going to do it. And so if when we're meeting and you're looking at some of these problems and you come up with more of how solutions, especially at the beginning, I'm going to be saying, no, we can't be looking at how. We really want to know what needs to be done. So now looking ahead at a little bit more detail associated with this, one of the ways you can make sure that you completely understand what the user needs, what the customer needs, is you can use something like scenario analysis. So defining the scenario and exploring the needs and interactions in that scenario. This might be something like put together an idea, well, what if there's an economic boom scenario and this company, their sales go through the roof? Are there any needs associated with that we need to keep in mind? Do we need to think about, scalability or flexibility? Or you might say, well, what if this the production manager in this particular facility is really interested in green kinds of activities? What if there's a new person in line that really wants to look at that? Are we going to incorporate that into the facility design? Also, you might want to really describe the user community. Who is it that is using this facility? Who are the people? How old are they? What are their skills? Do they have any special needs? Do they have any special training, or do they have any familiarity with things? Have they been exposed to some things? So really looking at who are the people that are using it. Identifying all the stakeholders. So this is another thing you want to do. Like, who cares? Who cares about this? The employees care because it's their quality of work. The managers care. The industrial engineers who work there care about that. And also avoid constraining the solution. Don't just say, oh, yes, we have to make it in this facility. If that isn't a requirement, make sure that you're not including that as a requirement unless it really is a requirement. Also, trying to get involved all different kinds of people. Don't just do this on your own. You will want to make sure that you're getting all of the stakeholders involved in it, whoever's interested in this procedure. So you definitely are going to be wanting to talk to the workers on the floor and seeing that their understanding of what's exactly going on here, but maybe even marketing people or purchasing people or anybody in maintenance that might be integrating with the facility. And then also make sure you document all your inadequacies. So if you've seen something, make sure you remember who said that. What interview was that? There should be somebody that's constantly keeping track of the documents that you're collecting. So this brings us up to what your first assignment for the project is to develop a project starter, a statement of work, responsibility matrix, a communication plan, all the things that would be involved in a project management kinds of things. Everybody in the group has already taken either 303 or 556, so this should be something that you should be able to do, and making sure that you produce this as one of the documents that is communicated to the client. So that really takes care of kind of the problems associated with defining the problems. And then the rest of the things associated with knowing the operations, you're going to continue on with that. We're going to be doing many things associated with that. One of them is time studies, operations process chart, bill of materials, parts list, flow process chart, exploded assembly diagram, assembly chart, route sheet, flow chart, Gantt chart, Pareto chart. All of these are things that we're going to be looking at in just a minute or in a later video about how to go through these operations. So we're going to look at time studies next, but I'm going to go ahead and stop this this part of the video, and we will look at it a little bit later.